Perform the indicated operation, then use a calculator to check your work. So for this first problem, we want to certainly pay attention to what's the indicated operation. We see the multiplication dot there, so we know that we're going to be doing a multiplication problem or a product. So when we multiply fractions, the basic idea is to just take numerator times numerator and to take denominator times denominator, 4 times 8. And when I put the numerators together and the denominators together, we can start looking for any common factors that there might be between the numerator and the denominator. And with these numbers, 3 and 7 in the numerator, 4 times 8 in the denominator, there's not going to be any factors that are going to be in common. So we can just go ahead and multiply straight across. 3 times 7 is 21, and 4 times 8 is 32. So that's going to be our final product. That's the final answer for our first problem. Now this next problem, we're going to have a few more things going on. If we put the numerators multiplied together for my new numerator, 8 times 3, and we put the denominators together, 9 times 10. Now before we do the multiplication, we can start looking for common factors between the numerators and the denominators. And there's lots of common factors that we're going to find here. We can see with the 8 and the 10, there's a common factor of 2. Now the author of the textbook that these problems are related to will talk about breaking these down all the way to their primes, but that's not really necessary if we have a good, strong mental multiplication chart. I can take a look at the 8 and the 10 and I can say, oh, there's a common factor of 2. So I'm going to rewrite 8 as 2 times 4. And I'm going to remember the 10's down in the denominator, so I'm going to rewrite the 10 as 2 times 5. And I'm going to see that the 2's are going to cancel out. I don't need to write the 4 all the way down as primes. I can go ahead and just leave that as a 4. Now when I look at the 3 and the 9, okay, we can see that there's common factors there as well. There's a common factor of 3. So if I rewrite 3 as just 3 times 1, and I rewrite the 9 as 3 times 3, I can see that the 3's, there's 1 3 in both the numerator and the denominator. 3 over 3 equals 1. So those are just going to cancel each other out. Now when I multiply the pieces that remain, 4 times 1 is 4, 3 times 5 is 15. Now some of you might have learned along the way that this step that we put here, where we took another step to rewrite the numerators and the denominators in this factored form, some of you may have learned to just sort of cross-cancel here with these numbers. Looking something like this, like with the 8/9 times 3/10. You might have just done this step as part of this. You might have said, oh yes, so 8 and 10 have a common factor of 2, 2 times 4, 2 times 5, and I know a lot of people don't even show the 2's in there. They would just cross those out and write a 4 and 5. But I think it's helpful to put the 2's in there to make sure we don't make any mistakes. And then with the 3 and the 9, 3 times 3, 3 times 1, and those 3's. And if you compare these two steps, you can see we've got the same pieces. They're just written out differently. And again, multiplying what's left, 4 times 1 is 4, and 3 times 5 is 15. Now we can use our calculator to double check our work using the fraction key on the calculator. So if we pull our calculator up here, our first problem, 3/4, so remember we do 3 fraction key 4, and then we multiply that by 7 fraction key 8, and we get the answer 21/32, just like we did when we worked it by hand. For the other problem, let's clear this out. We have 8/9, so 8 fraction key 9, and that's being multiplied by 3/10, 3 fraction key 10, and when we press enter, we end up with 4/15, just as we did when we worked it by hand.